All right, guys, so let's talk about some topic B skills. So topic B had us working with fractions that did not have like denominators. So instead of a half and a half, you're doing things like this first one, a half and a third. We know that we can't add or subtract fractions if their denominators are not matching. So step one in that scenario is always to change the denominators so that they are compatible, which means in this case, they need to be exactly the same. When we look at turning fractions into having common denominators, there are two ways to do that. One is a strategy that we call easiest common denominator, and then there is the more simplified and advanced version of using the least common denominator. I'm going to model with the easiest common denominator on this first one, which also happens to be the least common. So let's go ahead and jump right in with 1/2 and 1/3. When we're adding fractions like 1/2 and 1/3, the first thing we do to find the easiest common denominator is multiply those two numbers together. When we multiply 1/2 times 1/3, we get 6. So we know our new denominator is going to be 6. Now we need to multiply each fraction by the opposite denominator. So 1/2 is going to get multiplied by 3. This 1, 3 times 1 is now 3. And this 2, we're going to multiply over here. 2 times 1 is 2. So we're adding 3 plus 2 now in this scenario. So 3 plus 2 is 5. That's my new numerator. So I know now that my fraction is 5/6. One more time, how did we get that answer? Let's back up and look. The first thing we did was decide, okay, we need common denominators. To do that, I'm going to delete this so that we can backtrack. We first say, well, what are those denominators if we multiply them by each other? So 2 times 3 is 6, and that's how we got the 6. How did we get the 5? Well, we knew now that we had to multiply this 1/2 side by 3, which means that this right here, if we cross multiply, 3 times 1 is going to become a 3. And then we have to cross multiply on the other side as well. So we're going to do 2 times 1, and that 2 times 1 is going to be 2. We go back to the problem and say, what were we doing? Were we adding or subtracting? We always want to double check, especially now that we're doing both. And we were adding, and that's how we got the 5. So 1/2 plus 1/3 is the same as 5/6. Let's go down here to where we're using slightly bigger digits and our numerators are no longer 1. 3/4 plus 2/3. How are we going to tackle this problem? We're going to tackle it the exact same way using the easiest common denominator, which is multiplying 4 times 3. 4 times 3 is 12. So I know that's my new denominator. Now I have to figure out what's my new numerator. So I'm going to cross multiply. 4 times 2 is 8. Then I'm going to come here. 3 times 3 is 9. There's that funny 9 it likes to make. We are adding 9 plus 8. 9 plus 8 is 17. So my answer is going to be 17/12. However, I notice immediately that this is a fraction greater than 1, and I should not, as a 5th grader, be leaving my answer as a fraction greater than 1. I need to turn it into a mixed number. So to do that, if you remember from the last video, we're going to ask ourselves, how many 12s can we make out of 17? We can make 1/12. How many pieces will be left over? There will be 5 pieces left over. And each piece is what size? It's the size of a 12. And that's how we would do that one. If we come down to number 2, we're going to see that there are subtraction problems using the same skill. The only difference is that some of them have mixed numbers in the beginning, and that will require one extra step. So we're going to do these first two as an example. Let's start with 5/6 minus 1/4. We're going to follow the same strategy that we were just following. So in this case, we're going to multiply across. When we do that, we'll get 24 for our new denominator. Then we're going to cross multiply to find our numerators. 4 times 5, which is 20. 6 times 1, which is 6. We recall we're subtracting now, so we're at 20 minus 6. 20 minus 6 is 14. So my new numerator is 14. And my answer is 14/24. Now, as a fifth grader, I want to start looking at these answers and asking myself, is this the simplest way to write this number? If your top and bottom number are both even numbers, so they're numbers that you can get to by skip counting by 2, you can simplify it further. And try 2. So I know that 2 goes into 14 and 2 goes into 24. So 14 over 24, while correct, could also be written as the equivalent fraction, 12 in the denominator, 7 in the numerator, also known as 7/12. So if I turned in my answer as 7/12, and David turned his answer in as 14/24, we are both correct because those are equivalent fractions. This is acceptable. This is the goal. Can you simplify when you have a fraction that you can look at and say, you know what, I think I can reduce that. So now let's look at what do we do when there's a mixed number. The last problem we just solved followed the exact same steps as the ones we did with addition. The only difference was that here we were subtracting and above we were adding. This one is going to have one extra step because it has one extra issue. This is not just a fraction, it's a mixed number. When we are doing this and we're subtracting, it's best to go ahead and turn that first mixed number and a second one, if you have a second one, we just have the first one this time, into a fraction greater than 1. So 1 1/5. We have to ask ourselves, how many fifths are in 1 1/5? How many fifths is that? Well, I know that there's 5 fifths in every whole. And then you have one more. So that would be 6 fifths. Let's go ahead and use text because that's going to be wonky. Okay, so 1 1/5 is going to turn into 6 fifths. Then we're going to come over here, minus a third. So let's go ahead and set up the rest of our problem. We are not going to change a third because it's not a fraction greater than 1, so we're going to leave it as it is. And now we're just going to follow those exact same steps, guys, that we've been doing. Once you turn the mixed number into a fraction greater than 1, you're good to go. So here's our problem, 6 fifths minus 1/3. Let's do step 1, which is find your new denominator. 5 times 3 is going to be 15. Step 2 is to cross multiply to find your new numerators. 5 times 1 is 5. 3 times 6 is 18. We are subtracting. This was a subtraction problem, so it's important to rewrite your sign so you remember what you're doing. 18 minus 5 is 13. So our final answer is 13/15. When we look at 13/15 and we ask ourselves, can we simplify it? The answer is no. There's not a number that goes into 13 that also goes into 15 because 13 is what we like to call a prime number. Nothing goes into 13 except itself and 1. We look at it too, we want to ask ourselves, is it a fraction greater than 1? Do I need to rewrite it as a mixed number? No, 13 is less than 15, so this is not a fraction greater than 1. We do not have one whole yet. So just to recap, the strategy for adding and subtracting is exactly the same. It's just your operation that's different. You're still multiplying across to find your new denominator and diagonally to find your new numerators. Then you just pay attention to your sign. So now let's talk about what does this look like when we're attacking a word problem. And we are going to do, let's do number 4 together. Love that it has a mixed number. Okay, so number 4, Martin jogged around the lake in 1 1/4 hour. Esperanza jogged around the lake in 5/6 of an hour. How much longer did Martin take than Esperanza in hours? The first thing I notice is that this longer, how much longer, I'm finding the difference. So I am subtracting. I know when I'm subtracting, I always subtract the smaller number from the bigger number. So the bigger number needs to go first. I'm going to set up my subtraction problem as 1 1/4 minus 5/6. Now, step 2, since this is a subtraction problem and there is a mixed number, is to take that first fraction, 1 1/4, and turn it into a fraction greater than 1 so that I can subtract with it and use my cross multiplying technique. 1 1/4 is the same as 5/4. And now that I know that, I'm going to reset up my problem as 5/4 minus 5/6. You guys hear that whistling? Woody is having puppy dreams. All right, so now let's go ahead and set this up. 5/4 minus 5. Oh, let's see if the 6 is going to work or if it's going to go wonky on me. Oh, it worked. Equals what? Okay, you'll recall step 1 is go across for your new denominator. 4 times 6 is 24. And then we're going to cross multiply to find our new numerator. 6 times 5 is 30. Helps to know your math facts here, guys. 4 times 5 is 20. So I'm doing 30 minus 20, and 30 minus 20 is 10. So my new answer, my final answer is 10/24. I know that 10/24, 10 and 24 are both even numbers, so I can shrink them up by 2. If I divide 10 by 2, I get 5. And if I divide 24 by 2, I get 12. So I could also write 10/24 or 5/12 as my answer, and both of those should be accepted in this scenario.